Hello everyone, we are back with our quick tutorial. Wait, what am I doing on correlation? Maybe we are interested in the relationship between the number of times we brush our teeth and cavities. We collect information from 6 different people and we ask them how many times a day do you brush your teeth? And we ask them how many, and we ask their dentist how many cavities they had in the course of a year. We can plot this data on a scatter plot. This is obviously made up data, but what we see here is likely a negative correlation where the number of times we brush our teeth is low, we have a high number of cavities, and when the number of times we brush our teeth is high, we have a low number of cavities. So again, by plotting this information from the beginning, we can kind of get estimates as what we think that correlation is going to be. This is our formula for our correlation. This top numerator piece is our sum of deviation products. And the bottom is going to include our sums of squared x and our sums of squared y. Here, it will not matter which value is x and which value is y. So it doesn't matter if you set the number of times you brush your teeth as x and the number of cavities as y, or if you set the number of cavities as x and the number of times you brush your teeth as y. Either way, you're going to get the exact same formula or the exact same value from that. So that part won't really matter here for correlation. So let's go ahead and kind of play with these values. So we have the number of times we brush our teeth. If we calculate the mean for those values, we get a mean of 3.83. When we look at the score minus its mean, this is the same thing we've been doing all along with our sums of squared. First, calculating those deviation scores. We're going to take 1 minus 3.83, that gives us negative 2.83, 2 minus 3.83, that'll give us negative 1.83, etc., etc., etc. We will then square each of those values. So our negative 2.83 squared is 803, our negative 0.17 is 0.03, our positive 3.17 is 10.03. And we just add all 6 of those scores together and we have our sums of squared for x. Again, you could do this reversing. You could call this one y. For correlation, it's not going to matter. Our number of cavities, we will calculate the mean there for those 6 values, and we get 3.17. We calculate the deviation scores there, so we take 5 minus 3.17, that gives us 1.83. 4 minus 3.17 gives us 0.83, etc., etc., etc. We'll square each of those values and we'll add them together, and this will give us our sums of squared y of 10.83. The new piece, so we've done all of this before all along since chapter 4. Our new piece is this sum of deviation products, or the cross product deviations, where we take those deviation scores before we square them and we multiply them together. So that's why I have these columns highlighted in yellow, is we're going to take the deviation score of negative 2.83 and we're going to multiply it with the deviation score for y of 1.83. And that gives us a cross product deviation of negative 5.19. We'll do that for each of the values for each 6 patients, and then we will add those values together. That will give us our sum of products, or sum of cross product deviations, of negative 16.83. Notice that this value is negative. This is going to tell us that we're going to have a negative correlation. So the sign on that cross product deviations, if it's positive, we have a positive correlation. If it's negative, we have a negative correlation. Notice that this one can be negative because we are multiplying these deviation scores before we squared them. That's where we'll maintain that sign. So we get our sum of deviation products of negative 16.83. Our sums of squared x we calculated at 26.83. Our sums of squared of y we calculated at 10.83. We'll just multiply those two, take the square root of that. So we have negative 16.83 divided by the square root of 290.57. We'll do the math on that, and we get negative 16.83 divided by 17.05. When we do that value, we'll get negative 0.98. So again, you can see that there is likely a relationship between these two values. And that's how we calculate a correlation. Thanks. If you have any questions, feel free to email us and let us know. Thanks.